lecture, we have seen the pure birth model, important assumptions and probabilities. The basic probabilities like zero arrival in time interval t, and we have also seen zero arrivals means no arrivals. Otherwise, it becomes very difficult to understand. The zero arrival means no arrival. And we have also seen in the previous lecture that what is the probability of no arrival in sufficiently small time h, and thereafter what is the probability that at most one customer may arrive in the system in sufficiently small time interval h. Therefore, these three basic probabilities have been defined and justified by applying the exponential distribution. So now, later what we did, we formed all possible combinations of probability of n arrivals during the time t plus h. One time slot is significantly of the significant size is t, that is time interval or time duration, and another time slot which is very sufficiently small. So now we are merging both of the time intervals. So that time interval is going to be t plus h. Why we are going to do this one? Because the mathematics expression or law of the mathematics checks that if we add something sufficiently small, meaning thereby what does it mean? It means that we are going to verify the situation at instantaneous time. We must be remembered the instantaneous concept of the instantaneous is what? Concept of the instantaneous means the increment must be very small. And similarly, you take it for the case of limit also. In this very case, you will find the limit also. So instantaneous for instantaneous means at any fraction of the time, at any possible point of the time, we can take the decision or we can analyze the model. And therefore, this is very sufficiently small time h which has been added. So possibilities, only two possibilities we have. So probability of n arrivals during time t and probability of no arrival during time h. So p naught h and p and t by multiplication law of probability, because I already told you that arrival of n customers during time t is one event and arrival of no customer during sufficiently small time h, this is another event, but they are connected with and they are happening simultaneously, and therefore these events are known as a compound events. And in case of the compound event, this probability AB is equal to probability A and probability B when they are independent. So these are the basic formula of the probability which has been applied here. So probability this into probability this. Here again the probability of n minus 1 arrivals during time t and probability of single arrival during time sufficiently small time h. So in this way we are getting this part of the probability, they are multiplied. And if you remember, I told you this is plus. Why plus? Here is or, either this way or this way, and both ways are mutually exclusive, and therefore we add this probability. We substituted here p and t plus h, p and t 1 minus lambda h plus p n minus t into lambda h. As usual, I told you this is probability of single arrival. This is a probability of single arrival. At most single arrival, this is a probability of the zero arrival, and this is n, this is n minus 1 as usual. So, and in case this is condition when n is greater than 0. Now, another case is when n is equal to 0. N is equal to 0 means it has only this part. So P naught T plus H n, and this is P naught T and 1 minus lambda H. Only 0 customers are only no arrival means there is no customer, there is no arrival in the system. N is equal to 0 means there is no customer in the system. So n is greater than 0 and n is equal to 0. This is the beginning and this is ahead of it. So this is the set of equations, the probability equations, basic probability equations, that is denoted by A. These are two basic probability equations, also known as difference equation. Why this is known as a difference equation? Difference equation. There are two things. There are two variations. If you take in sense of discrete, then you are making n, you are again coming to n minus 1. So there is a difference of 1. You are taking 0 customer and then you are reaching 1 customer. So variation of 1. So in case of discrete variable, you are just distance is 1, but here distance is instantaneous. That is a h. H is added in T. But this part is a difference, and this is the sufficiently small unit of time h, and therefore this is known as a difference equation. Now we are going to elaborate and rearrange it. You look at, nothing is new, but how we are rearranging it. P and T plus H, P and T, just opened this interval, I mean this bracket, and then P and T plus H, we transferred P and T in this left hand side, and after all we are just dividing by H. H is available in the right hand side also. So when we divide from right hand side, H vanishes. And I told you what is the role of T. So T means, this T means that you are getting sufficient limit P and T minus H. This equation you please look at. I told you this H is sufficiently small so that we can come to the H is tending very, very small. A concept of the instantaneous variation. So right hand side gives you P and T lambda plus P and minus 1 T into lambda. That is denoted by a probability, I mean first derivative, or you can write here, no problem, d dt. Later we are going to write d dt, but this time we are going to write this symbol, the symbol of the first derivative. Similarly we just from A we can also get this for n is equal to 0. P, the first derivative, is defined in this way by doing the same process. For n is equal to 0, n is greater than 0. So these are two basic equations. Again, these are called probability differential differences. Since this is involved, therefore it is called the differential difference equation. Since it has the probability, it has involved the concept of probability, therefore It is known as a probability differential difference equation. Now let us go ahead and B. Let us take the combination B, and we have done nothing. We have simply substituted d dt in place of the dash. So we are getting this combination. Thereafter, what we are going to, these are two differential difference equations. And now how these equations will be solved. There is a now big question for the solution of these differential equations. How many differential equations we have? For n0, this is 1, and this is n. So total number of differential difference equation is what? Total number of differential difference equation is n plus 1.
Yes.
N plus 1. This is the total number of differential difference equations. Now we need to solve the total number of differential difference equations. So there are two important methods for solution of this differential difference equation. The first one is generating function method, and the second one is iteration method. So here we are going to take the help of the generating function method. So if you revisit and remember your previous knowledge about the generating function, of whose generating function we define, of whose whatever generating function we define, the function generate that one. Therefore its name is generating function method. For example, here we are going to take the help of the, since concept is involving the probability, and therefore the generating function will be probability generating function. What does it mean? Probability generating function means the probabilities will be generated. You look at, this is a probability generating function here. This is a probability generating function, meaning thereby this probability must be generated. And how this probability must be generated? How this probability must be generated? It is this PNT. Just look. This PNT. This PNT is the probability of n arrivals during the time t. And this probability means we need P0t or P0t, we need P1t, we need P2t, we need to have P3t, so forth, so on. So if we are able to get the P0t, P1t, so forth, so on, PNT separately. It is not separated here. It is a part of the function generating function, but ultimately we have to get PNT separately. And how this comes PNT, you have to check it, that its name is the probability generating function, so it has to generate the probability function, probabilities. So therefore ultimately I will show you, you must remember why this probability generating function, why its name is. I have given this reason, as I told you, this generates the probabilities PNT. But how? The question is how. It's interesting, but question is how. So we will check it. You have to keep on looking that where this question is going to be answered. Now both equations of C, as usual, As usual, both equations of C, we are taking both equations. Now both equations means one is P0T and another is PNT. So equations of C are multiplied. Now we are applying the generating function method. We have taken the generating function that we define the phi zt. This is generating function. Phi zt is equal to n sum over n ranging from 0 to infinity p and t z to the power n, and mod of z is less than equal to 1. That is, it is converging in this circle. You must be remembered this about the generating property of the generating function. This must converge in this circle. So convergence, circle of convergence is what? Circle of convergence is 1. Okay. And if it is not converging, this is not useful for us. And therefore, this is the probability phi zt is equal to, this is a probability generating function. We are going to use this probability generating function to go ahead. Both equations of C, P0T and PNT, if you remember, are multiplied by, we are going to multiply Z to the power 0, and this according to match, this Z to the power 0 will multiply the P0T or P0T, and the remaining will multiply the another one. So let us see how we are, what, look at, look here, this part we multiplied ddt as usual, ddt as usual. You look at, only we multiplied this thing here in both sides and here in both sides. N is equal to 0. This was the first. Second one is what? Multiply by z1, z to the power 1. So it is in the left, it is in the right, it is in the right. Similarly, z square, we multiply by z square, and z square, and then so forth, so on, so forth, so on, and condition is this, n is greater than equal to 1. So forth, so on, last one is z to the power n here, z to the power n here, and z to the power here. This you look at. Now, upon summing over n from 0 to infinity, all are added. All are added. You look here. All are added. D, dt outside, n is ranging from 0 to infinity, p and t, z to the power n. Here, this sum is working. All are summed, and this p and t, z to the power n, lambda is outside, and you take lambda z here, because just to match this one, you remember here, just to match this one, just to match this one, just to match this one, we have made this z minus 1 and 1 z taken outside. This is as usual, only a little modification is taking place here, and I think it has no problem. Then now that this range is also changing and is going to begin from 1, because this will give you 0, n minus 1 minus 1 p naught. Okay, so you cannot remain, or you retain 0 here. we cannot retain 0 here, because if you put 0 here, so probability -1 customers, it is not allowed, it is not justified. So this part is okay. I think there is no problem. Then we come to this part. We okay, whose microphone is on? Okay, so we continue this part. You just look at here. So up to here we finished. Now we simplify it. So by the definition of generating function, we simply substituted this value at the place of what? At the place of sum over n ranging from 0 to n p n t into z to the power n. So we have substituted this value. This is the function. But this is the probability generating function. Now you look at, we have also substituted for the expression. What was the expression you would like to see it? This expression. This expression is little bit different. This is Pn minus 1 T Z to the power n. So by the definition of phi z, by the definition of this phi z t, this is the generating function. This generating function is defined by what? This is defined simply the sum over n. N is ranging from 0 to, this is 0 to infinity. And here I would like to tell you, here is PNT to the into z to the power n. This is the phi zt generating function, probability generating function. In place of this also we have substituted this thing. This is also phi zt. Why? Because whatever you get by elaborating this series sum, what will happen? N is 0 means P0 T Z to the power 0. Here also N is 0, N is N minus 1. So if you put N minus 1, again you get P0 T and Z to the power 0.
Yes, sir.
So you will get the same expression in both of cases, and therefore we have substituted this thing. You just here sometimes you may get a little bit confused, but answer is this, and therefore I have put the question mark here also during making this lecture. So simply if you take common, so this is a simple mathematics. This comes as usual, and ultimately you get the ddt y z t is equal to lambda z minus 1 y z t, and this is nothing else but this is the first order linear differential equation. Zt is what? This is a phi zt. A phi zt, if you consider just like y, then you will get a very simple form of the differential equation, and it has the popular solution also. You may be remembering, it has a solution like this. it has a phi zt y. This is just like y. Phi zt means y. Phi zt is equal to c. C is a constant for the determination. E lambda. This is plus. By mistake, it was made minus. So this is plus, but you need not write plus. Lambda z minus 1 into t. This is a solution, and this solution is obtained for the standard first order linear differential equation. And what is C? C is a constant, and this constant needs to be determined. And you know, in case of differential equation, constant can only be evaluated or can only be computed if we are given the initial conditions. You may also remembering in case you are handling the differential equation, then for computing or for evaluating such kind of constants, we were given the initial boundary value condition, if you remember. In the similar manner, we have just put t is equal to 0. We have very good justification of t in our hand, and t is equal to 0 means we are talking about the initial stage of the system, that is t in a system is going to begin. And at t is equal to 0, what happens? At t is equal to 0, what happens? At t is equal to 0, you look at here, t is equal to 0. Let us have the justification. We have the, this is what? This is the generating function or probability generating function.
Yes.
Here, probability generating function, whenever I say generating function means you should not get something disturbed, because you have also the pure branches of mathematics. Here is the applied one, that is the probabilistic one. So P and T at t is equal to 0, let us examine the nature of this generating function. Nature of this generating function is what? yz0 is equal to p0, t has become 0, n is 0 in this very case. We have just elaborated it, expanded, opened the this summation, and this is n is equal to 1, but t remains to 0, and z to the power 1, so forth 1. This will continue. Next will be p2 0, z to the power 2, so forth 1. You look at here, this is very important for us. This part is very important to evaluate. Once we understand this part, then definitely we will understand this part, and so forth so on. P00. P00 is what? This is a probability that at time 0, that is in the beginning, there occurs no arrival. It is a 101% sure that in the beginning there is no arrival. So what is probability of this certain statement is always 1. This statement is correct. Is it
Yes,
clear
sir.
or not? This statement is very important. In
Yes,
time
sir.
t, there is no customer. It is a fact. When time is 0, there is no customer. This statement is correct, and therefore
Yes.
this is certain. Therefore, its probability is 1.
One.
Probability is not 0. Many times we get confused that probability must be 0. No, probability 0 is this one. Probability 0 is this one. What? Probability of one arrival in 0 time t. Probability of one arrival in time 0 in the beginning or in 0 time. If time is 0, then how the person can arrive, how the customers can arrive, meaning thereby this statement is false. So probability of the false statement is always 0, and therefore this all are 0, all are 0. When time is 0, then how we can get the probability. So these are 0. So in this way, we have got the zero probability of zero arrival. We have got the probability of one arrival, probability of two arrivals, supports one several arrivals in zero time, and that comes out to be 0. In this way, what we are going to have, phi z 0 is going to 1, t is equal to 0, 1. This is it. E from D, phi z 0, 0. This was the solution. So C e to the power minus lambda z to the power minus 1, t is equal to 0. This becomes whole thing 0. So this is C. This is 0 means 1. So this is equal to C, and both you compare. 1 is here, C is here. So IT is equal to 0. Phi z 0 is equal to C. In this way, we have E and F give us that how we can get C. C we have got in this way a initial value conditions. We have got the value of C. Now substitute C. Phi z t is equal to E lambda z minus 1 t. So this is plus, but you need not write in your note. Here by mistake it was. So now C1 is 1, and now e to the power lambda z minus 1 t is, this is a solution of the given differential equation. Okay, how many differential equations we have already? Remember this. This is the n minus 1 differential equations, and this is the solution. Now, what is more to discuss now? When we have received the solution, now let us talk about the probability generating function, because still we are not able to find out the separate probabilities, individual probabilities like P1T, P2T, P3T, P0T, Pn. So still we have tasks remained for discussion. So we further started discussing this very task of analyzing this part again. How we are going to analyze? We are going to analyze this part. As you look at here, you have seen. I told you, I shared this knowledge that since this is a probability generating function, since its name is a probability generating function, is it must generate PNT or probability. It must generate probability. It cannot happen that it is not going to generate probability. It must. If it is a must, then how we can get it? Let us see how. I have given it. Let us see how. So what we are going to do, z is a variable here. So we started assuming z is equal to 0. So one condition is that we are going to make the z is equal to 0. And the second condition is that we are going to check the variation in the sense that we are going to have the derivative, means the change of this function with respect to change in the independent variable, that is the z. And therefore here we have computed the first derivative, the of phi z, but at the same time we are taking z is equal to 0. Now z is equal to 0. So PNT and we have differentiated it. After differentiation, n is here, pnt is unaffected. Pnt is unaffected by differentiation because it does not involve z, but it has become n minus 1, and at z0, and this range, this is 1, this is not 0 again, otherwise problem will take place. What problem will take place? The problem, this n is equal to 0, so at this time everything will become 0, and therefore we are going to start from 1. This is not possible from 0. So we change this condition, and then we are going to have, look here, again something interesting. P, the first one is P1t z to the power 0, P2t, and this
2z. Yes, sir.
in case of this 2z, this is 2.
Yes, sir.
This is so this is 2z, and ultimately when you substitute z is equal to 0, this is z is equal to 0, then this part, since already this is z does not involve here, does not exist here, whenever we take z is equal to 0, when we substitute n is equal to 0, z is equal to 0, I mean this zn minus 1, then this is 0. So if it is 0, then this is only remaining, others are 0, 0, 0, because when you substitute 0, every term involves z, and therefore everything is 0. So ultimately we are going to have the z is equal to 0. The first derivative is p1t. Something is looking nice. You look at, we were interested in the probability like this because this must generate similarly. Similarly, you look at here, second derivative is going to have given like this, and third derivative and nth derivative factorial npnt. So in this way, we have taken the first derivative onwards, the up to the nth derivative, and we have got the values in terms of the probability. Now we have the generating function further, and we would like to generating function this, if you remember this, the solution. Then solution is also going to be evaluated because both are same. Then they must provide the same value, and then we will exploit this value, and the just now we have derived the values. We will equalize, and what we get, we will check on the next turn. So up to this part, I think I'm going to wind up today, and we will continue tomorrow. This just, I am explaining this mathematics for the sake of your interpretation, your knowledge, but you need not write all these basic things when you are going to have the derivation. You need not write so many languages behind every justification. You have to simply write the mathematical part thoroughly, and you need to put certain mathematical condition. At t is equal to 0, keep on writing, nothing else. N is equal to 0, n is greater than. These basic conditions we must not ignore. but we must not write all these very things, because in a limited time interval you have to prepare your question for the examination. But once your concept is clear, then you can get. So keep on consulting the previous questions also, so that at last we will try to respond on those questions. So okay, thank you very much.
Thank you, sir.